Welcome, agents. You've been assigned a new mission. The culprit you'll be looking for is vitamin B12 deficiency. His crime? Anemia. Your mission is to terminate the culprit. You're all aware of iron deficiencies and their part in the anemia crime ring, but we received some new intel that vitamin B12 deficiencies have a big role in anemia as well. These deficiencies can lead to a special type of anemia called Megaloblastic Anemia. Red blood cells have a high cell division rate, and this type of anemia occurs when red blood cell replication is impeded. Because of this, these cells will be bigger than normal and smaller in count, leading to symptoms like fatigue, weakness, and shortness of breath. Why is this? Vitamin B12 contributes to processes involved in cell division and DNA replication, like chromatin remodeling, gene transcription, and nucleotide synthesis. So vitamin B12 deficiencies can lead to problems with cell division. Let's look into this mechanism. Vitamin B12 is a cofactor for an enzyme called methionine synthase, or MTR. 5-methyl-THF transfers its methyl group to vitamin B12, which then transfers that methyl group to homocysteine, which turns into methionine. Methionine then reacts with an ATP molecule and becomes S-adenosylmethionine, or SAM, the universal methyl donor, essential for DNA methylation reactions. These methylation reactions are also important for hundreds of reactions, including the regulation of genes. Vitamin B12 is also very important for nucleotide synthesis. After giving its methyl group to vitamin B12, 5-methyl-THF is converted to THF. THF can then be converted to 10-formyl-THF by the enzyme MTHFD1. 10-formyl-THF can then be converted into nucleotides, specifically purines such as adenine and guanine. And from 5,10-methylene-THF, also synthesized by MTHFD1, we can get thymidine, which is also the rate-limiting nucleotide for DNA synthesis. So without B12, MTR can't work. You will have no conversion to THF, leading to accumulating 5-methyl-THF, also known as the methyl trap, because the methyl group is now stuck there and can't transfer to B12, impairing nucleotide synthesis and DNA replication. You will also have no homocysteine to methionine conversion, and therefore no S-adenosylmethionine, or SAM, leading to reduced methylation reactions. This negatively affects how genes are regulated and hundreds of other processes within the cell. We can see, therefore, that vitamin B12 plays an essential role in DNA replication, and our main culprit, vitamin B12 deficiencies, deter cell division, which impacts cells like red blood cells, which divide frequently. This is a primary reason behind megaloblastic anemia. Why is this important, though? Well, vitamin B12 deficiencies prey on the vulnerable, especially those susceptible populations in developing and third world countries. On top of that, their victims of choice are women and children. In fact, our intel sources found that in a randomized control trial in India, 51% of pregnant women enrolled were vitamin B12 deficient, making them at risk for anemia, and anemia during pregnancy can lead to growth and development defects in the infant. Some of these defects include neural tube defects, or NTDs, where there are abnormalities in the baby's spinal cord development. The child can also have or be susceptible to anemia and stunted growth and development. So back to the mission. Vitamin B12 deficiencies may not be as well known of a culprit when thinking about anemia, especially with the iron overlord, but it is just as important in terms of the anemia crime ring. This is especially true in populations more at risk for this disease, such as women and children. Good luck on your mission, agents, and make sure to stop vitamin B12 deficiencies. The people of this world are counting on you.
Created using Powtoon.